In the stillness of an Italian night in 1609, a lone figure peered through a curious contraption poised towards the heavens. Through this modest telescope, Galileo Galilei was about to trigger an intellectual revolution. Within the thinnest slivers of light captured by his lens, he found glaring evidence that would challenge the cosmos as understood for millennia. In 1609, inspired by reports of a Dutch spectacle maker creating a device that made distant objects appear closer, Galileo, a professor of mathematics at the University of Padua, decided to develop his own version. Galileo's genius lay not just in replication, but in enhancement. He improved the magnifying power of his telescope significantly, from a modest threefold increase to an unprecedented 30-fold. This improvement allowed for an unparalleled exploration of the celestial sphere. His telescope, comprising a convex objective lens and a concave eyepiece, was crude by today's standards, but was a marvel of technology at the time. His instrument was about as long as a dining table sword and only an inch in diameter, made from finely crafted wood and leather. Despite its simplicity, Galileo's telescope enabled him to magnify images up to 30 times, revealing the craters of the Moon, the phases of Venus and Jupiter's largest moons, sights never before seen by the human eye. Galileo's relentless dedication and these refined observational methods formed the backbone of what would come to be known as modern astronomy. By pointing his telescope to the heavens, Galileo not only saw beyond the limits of human vision, but also beyond the constraints of contemporary scientific understanding. The significant revelations began on January 7, 1610, when Galileo first turned his telescope towards Jupiter. Over subsequent nights, he noticed what appeared to be 3 small, bright stars near the planet, which seemed to shift positions relative to Jupiter. This observation was contrary to the prevailing Ptolemaic model of the universe, which posited that all celestial bodies should revolve around the Earth. These stars were actually moons orbiting Jupiter, which he later named Io, Europa, Ganymede, and Callisto. This discovery provided concrete evidence that not everything in the universe orbited the Earth, a cornerstone of the heliocentric theory posited by Copernicus. By observing the phases of Venus, Galileo delivered another significant blow to geocentrism. His telescope showed that Venus exhibited a full set of phases, much like the Moon, which indicated that it orbited the Sun, not Earth. This observation was incompatible with the geocentric model, but was predicted by the heliocentric model. Galileo's telescopic observations marked a significant departure from reliance on ancient authorities and emphasized a methodological reliance on empirical evidence, an approach that became a hallmark of the scientific revolution. His work laid down the fundamental principle that observation should guide theory, not the reverse. This shift not only transformed astronomy, but also altered the course of science in general, emphasizing an evidence-based approach to understanding nature. The broader impact of Galileo's discoveries extends beyond mere academic circles. It fundamentally altered human conception of its place in the cosmos. By showing that Earth was not the center of everything, Galileo challenged the anthropocentric view that had dominated human thought for centuries. This brave ushering in of the modern scientific era is a testament to the power of observation, inquiry, and perhaps most importantly, the courage to question enduring beliefs. In conclusion, Galileo's telescope was more than an optical instrument. It was a symbol of the awakening of human curiosity, a beacon that lit the way for the exploration of the cosmos. It brought humanity face to face with the vast, intricate universe,